Hello, class. For this next problem, I'm going to do from page 183, question number 1A, from section 3.4. This is to decide whether the equations form a cubic spline. We have s of x is equal to, we have x cubed plus x minus 1, and the closed interval 0 to 1. And then negative x minus 1 cubed plus 3 times x minus 1 squared plus 3 times x minus 1 plus 1. And again, the closed interval 1 to 2. And in order for us to have a cubic spline, one of the many properties, or one of the couple of properties that we would need to verify is if the value, we take the derivative of the first equation, if at the endpoint here that they share, so here they share 1, so this would be at 1, whether or not it's equal to the derivative of that second equation at, again, the endpoint of 1. Again, it's this value of 1 because they share 1 in the closed intervals. So it's basically where they're overlapping. In order to do that, we need to take the derivatives first. So derivative of the first equation from the set we would have as 3x squared plus 1. The second equation, the derivative of the second equation, we would obtain, and this is not completely multiplied out, but that's perfectly fine, negative 3 times x minus 1 squared plus 6 times x minus 1. Then we would have plus 3 due to this last term. Those are our two derivatives. And if we put 1 into this first derivative that we just found from the first equation, we get 3 times 1 squared plus 1. That'll give us a value of 4. And if we put 1 into the derivative of the second equation, we would obtain negative 3 times 1 minus 1 squared plus 6 times 1 minus 1 plus 3. Most of that cancels out because of all the zeros. We get a value of 3. And from this, we could see that the derivative of the first equation at 1 does not equal the derivative of the second equation at 1. So because of this, s of x then is not a cubic spline based upon those definitions that we had. Let me know if you have any questions or concerns. Thank you.